Today we're going to build on the concepts we learned yesterday and talk about a cumulative frequency and a cumulative proportion. If you look at the chart below, this is the data chart we had seen yesterday in our notes regarding the age of U.S. presidents when they were inaugurated. And we filled out the frequency based on the data, and then we figured out the proportion of the total data. And we saw that our proportion always added up to 1. Well, cumulative frequency means the total frequency up to and including the class in question, and the same thing applies to proportion. So if I were filling out the cumulative frequency for this data chart here, my first class would have a 2, my second class would be 2 plus 7 or 9, and then add 13, giving me 22, 34, 41, and 44. Now when we're dealing with a cumulative frequency and a cumulative proportion, our final number is always going to be our total number of data, and our cumulative proportion is always going to add up to 1. So in this case, I would do 2 out of 44, 9 out of 44, 22 out of 44, and so on. And each of these decibels would represent the proportion of the total data that was at that point or below. And as you can see, as we get to the very end, that these add up to equal 1.00. Now, if you were to use the round decimals in the proportion chart, this might be off by a little bit, which is why I would recommend figuring out your cumulative proportion the way that I did over here, using our cumulative frequency divided by the total. The next few questions ask us about how a cumulative frequency compares to a typical frequency diagram. As you can see, for each row, our cumulative frequency is greater than or equal to our frequency. The only way that they would be equal would be if there was no increase for that class. As far as how does a cumulative frequency entry in the final row compare to the entries in the frequency column, the sum of all of the frequencies is going to equal that last row, which is what we said right here when we said it's equal to our total. And then what's always going to be true about the last entry in the cumulative proportion column? This will always equal up to 1. So here we will always equal 1. Here this will equal the sum total of frequencies, and the cumulative frequency is always going to be greater than or equal to the regular frequency. Now below I want you to make a well-labeled cumulative frequency histogram of the data. A well-labeled histogram means that it will have the labels for both axes and a title for the graph. We will have our x-axis labeled like a number line, the way that we talked yesterday, and the bars will be touching. So pause the video and make your frequency histogram. I want you to notice when you look at this diagram that first of all of the bars are touching. Second of all, notice this double hatch mark that we have here, and that shows that my axis starts at 40 and part of my axis has been removed. We can see that we have labels on all of our axes and a title for the graph. Now there's a question posed to the right that says, will each bar always be higher than the previous bar? And each bar will either be at least as great as or taller, but that will not always be higher. So the answer to that question is no. They could be the same height if there was no increase. However, we will never see the bars decrease in height when it is a cumulative frequency histogram. Next, we're going to talk about the shape of histogram. There are 3 words that we will hear used very frequently: symmetric, right skew, and left skew. The first, symmetric, is pretty self-explanatory, and in this case the graph is usually a mirror image. In this case, the mean is very similar to the median. They are very close together. In the second case, we have what's called a right skew. And in a right skew, the right side extends much further out than the left. And that would be a graph that kind of looks like this. We might have the majority of the data clumped here, and then some stragglers down there. And this part right here that's kind of your stragglers is what we call the tail. And when you have a tail to the right, that means that there are a few scores off to the right that are much greater than the majority of the data. And those greater scores are going to skew our data, and in that case our mean is typically greater than our median. The median is the middle of our distribution, and if we have some scores that are much larger than the majority of the data, they can affect your mean. Next, we have what is called a left skew. And in a left skew graph, we see that we have a tail on the left-hand side of our graph. So that might be when you're typically, scoring grades in the 80s and 90s, and then you get this random 50% on a quiz or a test. And that would pull down your average. So in this case, we say that our mean is less than our median. Now in this next problem set, I want you to take a look at the histogram that we see below and analyze the questions. First, we can see that the shape of the graph is what we would consider to be left skew, or skew left. And that's because as we look at our graph, if we were to draw the shape over it, we have a long tail to the left and the majority of the scores clump to the right. Now, in order to answer the rest of the questions, I have to figure out how many scores I have. And by adding up all of these frequencies, I can see that I have 35 scores. To get the median score, I would take 35 and I would divide it by 2, which gives me 17.5. And we learned the other day that when I have a 0.5, I round up to the next score. So I'm going to look for the 18th score. And as I count all the frequencies, I can see that the 17th score is in the column of 96. Therefore, the 18th score would be in the column for 97. So if I were to list all of these out in order, then 97 would be the median score, or the middle score. Now to get the mean score, I have to add up all of my percentages. Now the easiest way to do this is to add them up, such as I have 86 plus 87 plus 2 times 88 plus 90, and so on. And so then when I get to the scores that have higher frequencies, for example, the 98, I would just do 98 times 7. So after adding all of these up, I get a sum total of 3,338. And when I divide this by 35, I get that I have a mean score of 95.371%. The mode is going to be the score that occurs the most, and the score that occurs the most is the 98. In order to find my range, I want to do high minus low. And my highest score is 100, my lowest score is 86, so 100 minus 86 gives me 14. Now when I look at the score and I'm asked below to describe it in terms of its shape and measure of center, some things that I want to focus on are the fact that my mean is lower than my median, and that occurs when I have a left skew because I have lower scores that pull down my average. A nice summary that I wrote at the bottom says the graph is skewed left, meaning there are lower scores spread far below the majority of the scores. These scores pull down the average, which explains why it is lower than the median. Since the mean is easily affected by these scores, we say that it is not resistant, whereas our median is a resistant statistic. And these are words that we will talk about quite a bit. Not resistant and resistant. And again, the fact that those few low scores can affect my mean by almost 2 percentage points shows just how non-resistant the mean is. For this next problem set, we want to look at our graph. And this graph would be what we call symmetric. It looks very similarly to being mirror image on either sides of the graph. Now the median, again, that is found by finding the middle number. And if we count the total number of pets, we can see that we have 10, 13, 15, 19, 25, we have 28 pets, and if I do 28 divided by 2, I will get 14. In this case, I need to average my 14th and my 15th score. So again, we look on our data chart and we count in 14 scores. So here's 4, then I have 10, 13, so my 14th and 15th scores will appear in my number of 4 pets. So that means that 4 pets is my median. The mean we find by doing the average, and in this case we would add them all up and divide by 28. We find that to be 3.929. In terms of my mode, this graph is bimodal. There are 2 modes, 6 pets and 2 pets. And to get my range, again I do high score minus the low score. Now this is not high frequency minus low frequency, this is high score, which would be 7 pets minus 1 pet, which is 6 pence. Now we want to talk about the relationship between the graph's shape and center, and we can see here that the mean and the median are very close together. When the mean and median are very close together, that is often apparent in a symmetric graph, which is what we see here. So in this graph, we say that it's symmetric, the mean is approximately equal to the median, and in this case, both the mean and the median are accurate descriptions of the center of the graph. Alright, complete the last example and then unpause the video to check your answers. In this last example, we can see this is another scenario of a symmetric graph. The median is found to be 8. To find our mean, we add up all of the ghosts cited by their frequencies and divide by 22, which gives us 8.409. The mode is also 8. The range, we get 7. This graph is also fairly symmetrical, and the mean and median are also fairly close together. Alright, that is all. Homework, worksheet 3.